Hey guys, welcome to our channel. Before starting the video, if you have not subscribed our channel till now, then please subscribe it. This video series will help you to learn Spring advanced features. In this video, we will see what is Dispatcher Servlet. Dispatcher Servlet is the class which manages the entire request handling process. Like a normal servlet, Dispatcher Servlet also needs to be configured in the web deployment. The script are web.xml. By default, Dispatcher Servlet will look for a name Dispatcher Servlet.xml to load the Spring MVC configuration. Here is sample code. Let's implement. Let's create new Maven project. And select Artifacted as a web app. Click on Next. Enter some group ID. So group ID is nothing but project structure and Artifacted is a project name. Click on Finish. The project created and project starts downloading. As you can see inside JSP giving some error, it is like HTTP servlet is not found. So let's add an additional dependency from Tomcat. To add new jar file, click on project, click on build path, under build path configure build path. Under libraries click on add external jars. The HTTP servlet related jar you can find under Tomcat. Search the jar file under lib folder and we need to add Servlet API jar file. Select and click on open. Now click on OK. See error gone. Now let's add some command to run this project. Click on the project under Run as click on Maven Build. Under Goals, you can use this command, so the benefit of this is like you can directly run the project. So here is the command. See, project starts to run. See run complete. You can see under log URL also there. Let's copy URL and open it in the browser. See as output comes as hello world. Now let's search for Spring Web MVC dependency. Let's select version 4.0.1 and click on that link. Let's copy this dependency. Let's paste it into POM.xml file. Now let's add Dispatcher Servlet related code in web.xml file. I hope you know the legacy code when we create a new server, and to map that we need to add code for that servlet in web.xml file. The same way we are adding Dispatcher Servlet mapping code. So this Dispatcher Servlet is a part of Spring framework, so we don't need to write any legacy code. That's why we use the framework. Let's open this class. As you can see the documentation, you can go through that. As you can see, we have given a servlet named Dispatcher, so we will follow kind of naming convention. For configuration, XML file name starts with the Dispatcher file created. Let's search for namespace like Spring Beans context namespace. Let's open Spring documentation. Let's search for context. Here it is. Let's copy this and paste it into configuration related XML file. Here are the common steps to configure the web application. First, we will add View Resolver. If you already watched Spring Core video, then cool, otherwise watches it. that will help you to understand. Here I am creating a new bean for ViewResolver. There are so many types of ViewResolver provided by Spring, you can add anyone. I am adding internal resource ViewResolver. Let's open this class. As you can see, some JSP/JSTL. With the help of this, we can easily integrate with JSP. Under this, let's add JSP related properties. Like view class. Prefix and suffix. Like whatever path we gave for prefix, so the same pattern. Let's create a folder under web app, so this folder will contain all the JSPs. Let's create new JSP file called welcome.jsp and add some message. Next, we need to add context component scan that will contain base package detail, and it helps to identify component classes like controller, service, repository. Now let's create a package with the same like we have given. And create a new class under controller called welcome controller. Annotate this class as controller. Now let's see how to map that JSP which we created. What code is required? I hope you know this basic code. That's it for this class. Let's look for the JSTL dependency. Copy and paste it as POM XML file. Now let's add simple code to index.jsp file. This is like we adding, so when the application opens automatically redirect to welcome page. Add some print log. Let's run this. Run successfully. Let's open in browser. See the welcome message is coming. As you can see, controller log also is there. Observe the console log, it helps you to understand the flow in a more clear way. Let's review whatever we added. In this video, we will see what is init param and how to change dispatcher servlet name and default location, what is init param and context config location. Servlet init parameters. A servlet's init method is called when the servlet container loads the servlet for the first time. If we want to change the name of the dispatcher servlet file name or change its location, we can add init param with context config location as param name, as can be seen below. Let's implement. Let's first remove the dependency of the index.jsp. Let's delete this JSP. Let's remove this JSTL dependency, see any problem comes or not. From controller also change request mapping, so instead of welcome change it to /only. Let's run and see it's working or not. See server started. Let's check in browser welcome page is coming or not. Oops, 500 error. Let's check the reason. It's related to JSTL utils. JSTL dependency is required because for view resolver we are using JSTL view. Put it back JSTL dependency. Let's run again. Server started. See it's working fine and now can access the directly welcome page. Let's add some config location logic. As you can see, param name we are giving context config location and value we are giving the location where we want to keep XML file. Let's follow the same. Let's run again. Server started. See it's working, able to access XML file from the new location because of context config location. Let's change the name. Instead of dispatcher use something else. Changed from the dispatcher to Spring. Let's run again. Server started. See it's working. See the same location is available in log also. Let's review whatever we added. In this video, we will see what is the load on startup and what is the use of load on startup in web XML file and how it affects in Spring MVC. The load on startup is a tag element which appears inside servlet tag in web.xml. This tag specifies that the servlet should be loaded automatically on the startup of the web application. The load on startup value is a positive integer or 0 which specifies the servlet's loaded order as per your business logic or what suits your application. When the servlet is loaded by the container, its init method is called. If the load on startup is a negative integer or the element is not presented, then servlets will be loaded when the container decides it needs to be loaded. Here is the syntax. Let's implement. Let's run the application. Server started. As you can see in the log, there is no log for dispatcher servlet. Let's open the URL in the browser. It loading dispatcher servlet after hit the URL, as you can see in the log. Now let's put the load on startup in web.xml file for dispatcher servlet. Put the value 1. As I said earlier, the load on startup value is a positive integer or 0 which specifies the servlet's loaded order as per your business logic or what suits your application. Let's run again the application. As you can see in the log, dispatcher servlet also loading. I hope you got the idea about the load on startup and what happens before loading on startup and after load on startup. Same way you can put the load on startup for multiple servlets and give value in the order you want to load servlets. And when you hit the URL, only controller log is coming. In this video, we will see what is the role of context in Spring Framework. What is a context in Java? A context can be said as the running environment that is provided to the current unit of work. It may be the environment variables, instance variables, state of the classes, and so on. Like servlet, context represents the servlet's environment within its container, similar to application context, which represents the Spring application's core environment within the Spring container. There are servlets, servlet context, JSF spaces context, Spring's application context, JNDI's initial context, and all these contexts follow the facade pattern to abstract the environment, specific details to the end user, providing the interface methods to interact with. Spring context configuration. In Spring Web Applications, there are two contexts that get initialized at server startup, each of which is configured and initialized differently. Application context. Web application context. What is application context? Application context defines the beans that are shared among all the servlets. In application context, Spring loads application context.xml file and creates the context for the whole application using context loader listener that we define in our application's web.xml. Application context.xml is the root context configuration for every web application. There will be only one application context per web application. If you are not explicitly declaring the context configuration file name in web.xml using the context config location param, Spring will search for the application context.xml under web.inf folder and throw file not found exception, if it could not find this file. Beans that defines your business logic, database interaction and other stuff that has to be shared across servlets should reside in application context.xml. This is the part of web.xml file. In the above configuration, we are asking Spring to load root context.xml and create an application context from it. If context config location is not mentioned as in the above snippet, it will by default look for application context.xml. At server startup, context loader listener instantiates all being defined in the application context.xml assuming you have defined the following in context.xml file. The beans are instantiated from all four configuration files: test1.xml, test2.xml, test3.xml, test4.xml. What is web application context? There can be multiple web application contexts in a single web application. It is another servlet-specific context that is loaded based on the dispatcher servlets configured in the application's web.xml file. Each dispatcher servlet has its own servlet context initialized from servlet name servlet.xml file. This allows us to categorize the incoming requests based on the servlet's URL pattern and handle them accordingly, such that one of the dispatcher servlets could help to serve the web pages via controller, while another one could be used to implement a stateless REST web service. We understand that a single web application can have multiple dispatcher servlet configurations. Dispatcher servlet.xml defines the beans that are related only to that servlet, beans that deals with servlet requests. Web requests like controllers, message converters, interceptors should reside in dispatcher servlet.xml. If we want to change the name of the dispatcher servlet file name or change its location, we can add an param with context config location as param name, as can be seen below. So with Spring Servlet init param specified as in the above web.xml code snippet, Spring no more finds the dispatcher servlet context file with the name Spring Servlet.xml, but instead looks for the one specified as the init param value for context config location, that is Spring Servlet.xml. Object creations workflow. When Tomcat starts, beans defined in dispatcher servlet.xml are instantiated. Dispatcher servlet extends framework servlet. In framework servlet, bean instantiation takes place for the dispatcher. In our case, dispatcher is framework servlet. The beans are all instantiated from all four test1.xml, test2.xml, test3.xml, test4.xml. After the completion of bean instantiation defined in the application context.xml, then beans defined in dispatcher servlet.xml are instantiated. Instantiation order is root is application context, then framework servlet. Difference between the two contexts. Application context is the root context that has been configurations we might want to use and reuse across the entire application as singletons. There can be multiple web application contexts for each of the dispatcher servlets we specify in our application's web.xml. Web application context internally extends application context, and as a child inherits all the beans from its parent, so we can also override a parent bean within our web application context. It's always better to keep a clear separation between middle-tier services such as business logic components and data access classes, which we prefer defining in the application context XML, and web-related components such as controllers and view resolvers, which we prefer defining in the respective dispatcher servlet's web application context. Configuring context loader listener is completely optional. We can boot up a Spring application with just the dispatcher servlet, without even configuring context loader listener, that loads up the root context. Let's implement. I hope you already watched previous videos. Let's add what are the things required for the application context. So first starts from web.xml. Add a listener called context loader listener. It extends context loader and implements servlet context listener. If we go via documentation provided by Spring, a bootstrap listener to start up and shut down Spring's root web application context simply delegates context loader as well as the context cleanup listener. This listener should be registered after log4j config listener in web.xml if the letter is used. As of Spring 3.1, Context Loader Listener supports injecting the root web application context via the Context Loader Listener constructor, allowing for programmatic configuration in Servlet 3.0 plus environments. Let's run this and see it's working or giving any error. Why am I running? So at least we'll get error one by one, so it helps you to remember the solution. As you can see, we are getting many exceptions. Let's see what is the first one, being definition store exception. So it looks like after adding listener it's looking for application context XML file under ribbon directory. So after putting context loader listener, it will search for application context XML file. Let's create the XML file, same name whatever coming in the log. Let's run again and see what happens. Still some error. Now it's telling line 1 in XML document from Servlet context resource is invalid, obviously because new file is empty. Let's paste same bean definition like Spring Servlet XML. We are not putting anything related to context, so context-related namespace is not required. Let's run again and see what happens. See, it's working. Let's open the URL in the browser. See, it's working. As you can see in the log, initializing Spring Root web application context and other stuff. As per the log can see, first application context is loading, then Spring Servlet XML. Let's create service and DAO layer, so create respected packages. Create separate application context file for each and every layer. Name itself, you can see service related stuff will contain the application context service.xml, and database related stuff will contain by the application context Hibernate.xml file. To identify service and DAO layer, need to add context component scan and put the package name. And all newly created application contexts XML files need to import an application context XML file. See how simple is it? Same way you can create any number of context XML files to as per the requirement. Let's run again and see what happens. See, it's working. Observe the log. It maintain order, so first application context, then service, then Hibernate, and last Spring Servlet XML. Let's change the place and name of all context-related XML file using context config location. I already explained all this in previous videos. I changed from application context to Spring Contextor and move it under resources folder, that is nothing but the class path, and same way I modify name for other XML files. All good, let's run again and see what happens. See, it's working. In this video, we will see the complete flow from controller to DAO. Let's run this first. Server started. Let's open in browser. See, it's working. Let's add some simple changes so it will help to understand the flow. Let's run again, see changes are reflecting or not. See, login text is coming. Let's create a login page. See, changes are reflecting. Now let's add backend code. Let's add some more layer-like service on DAO. I hope you watched previous videos, so it helps you to understand. Let's run again and see log is coming or not. See, log is printing, that means the flow is working properly. In this video, we will see what is aspect-oriented programming. Aspect-oriented programming, AOP, complements object-oriented programming, OOP, by providing another way of thinking about program structure. The key unit of modularity in OOP is the class, whereas in OP the unit of modularity is the aspect. OP entails breaking down program logic into distinct parts called so-called concerns. The functions that span multiple points of an application are called cross-cutting concerns, and these cross-cutting concerns are conceptually separate from the application's business logic. A scenario where we should use OP: logging, auditing, declarative transactions, security, caching. OP concepts. Aspect: a modularization of a concern that cuts across multiple classes. Transaction management is a good example of a cross-cutting concern in enterprise Java applications. In Spring OP, aspects are implemented using regular classes, the schema-based approach, or regular classes annotated with the @aspect annotation, the @aspect style. A point during the execution of a program, such as the execution of a method or the handling of an exception. In Spring OP, a join point always represents a method of execution. Advice: the action was taken by an aspect at a particular join point. Different types of advice include around, before and after advice. Many OP frameworks, including Spring, model an advice as an interceptor, maintaining a chain of interceptors around the join point. Point cut: a predicate that matches join point. Advice is associated with the point cut expression and runs at any join point matched by the point cut. For example, the execution of a method with a certain name. The concept of join points as matched by point cut expressions is central to UP, and Spring uses the aspect point cut expression language by default. Let's implement. Before starting anything, let's run and see whatever we implemented it's working or not. Server started. See, it's working fine. Now let's search for the app-related dependency, and to enable app we need a namespace for that. First one, aspect JWeaver. Copy and paste it in POM XML file. Now let's search for Spring App namespace XML. Go with the Spring documentation. Here it is. Let's copy this and paste it in Spring Servlet XML file. Now we need to enable using app aspect JAuto proxy. That's it for XML. Now let's add Java-related configuration. Better create a separate package. Package ends with an aspect. Create a new class called logger aspect. Annotate this class as an aspect. Create a point cut. Star means anything. The dot means any number of parameter. The first star represents package suffix, the second star represents the class, the third star represents method, and dot represents variable arguments or no of method parameter 4. Now we need a join point. And that method annotate with the advice like here before, same way you can use after triple etc. Now put some system out so come to know which method is executing. Entire app works on proxy design pattern. Whatever method I am calling, these all are related to Reflection API. Move the sub property before context component scan. Let's run and see it's working or not. Server started. Let's open same in the browser and see log is printing or not. Oops, it's not printing. I think forgot something. Aspect class need to annotate with the component as well. Let's run again. Server started. Hit the URL. As you can see, two welcome messages are printing, one from app and other what we put earlier. Let's remove previous messages. Removed all the system out. Let's see it's coming from aspect or not. Let's run again. Server started. See it's coming. See it's working. Let's review whatever we added. In this video, we will see how to integrate Log4j and Spring Framework. Let's search for Log4j Maven dependency. Let's copy this. Before paste, let's run this, see it's working fine or not. Service started. Let's check in the browser. See it's working, as we added in last video system out, so system out messages are coming properly. So as you know, this is not the right way to print anything in the console. Better we should use Log4j API. Let's paste the copied dependency. Along with that, we need Log4j properties file. Let's create one property file. Let's search for Log4j property sample file. Go with Oracle link. When you open this link, there are so many samples are available. For this time I am just copying the first one and paste it in log4j.properties file. Adding some small changes for this time, changing from error to info. Same way users can set another kind of mode like debug, and removing some unwanted line of code. Let's run again and see it's working or not. As you can see now, there are so many logs are coming, and it's working fine. Now let's add changes in logger aspect class, so instead of the system out, it should be logger info or debug. For this time I am using info log4j. As you can see, changes looks very simple, and now change system out to logger.info. That's it. Let's run and see it's working or not. It's working fine. Let's review whatever changes we added. In this video, we will see what is MVC annotation-driven tag in Spring. Spring 3 introduces an MVC XML configuration namespace that simplifies the setup of Spring MVC inside your web application. If you don't include MVC annotation-driven tag, then also your MVC application would work. If you have used the context component scan for creating the beans or defined the beans in your XML file. MVC annotation-driven does some extra job on configuring the special beans that would not have been configured if you are not using this element in your XML file. This tag would register the handler mapping and handler adapter required to dispatch requests to your controllers. Let's implement. Let's run and see before MVC annotation-driven tag what is the output. Let's copy this, keep it in Notepad so later can compare. Now let's add MVC annotation-driven tag in Spring Servlet XML file. Need to add the namespace, so let's copy from up and change up to MVC. After change mouse over, if link it valid, then below the line will come "It's coming." Means it's valid. Let's add the desired tag. See, that's it. Let's run. After MVC annotation-driven tag in the XML output. See it ran successfully. Let's copy this and paste it in Notepad. Let's compare both the output, initialization started, and after that all XML-related log is common. URL path is coming different. Previous default annotation handler mapping and after request mapping handler mapping. I hope it helps you to remember the difference. In this video, we will see how to integrate Hibernate with Spring MVC. What is Hibernate? It is an object relational mapping (ORM) framework for the Java language. It provides a framework for mapping an object-oriented domain model to a relational database. It solves object relational impedance mismatch problems by replacing direct persistent database accesses with high-level object handling functions. Its primary feature is mapping from Java classes to database tables and mapping from Java data types to SQL data types. It also provides data query and retrieval facilities. It generates SQL calls and relieves the developer from manual handling and object conversion of the result set. What is Session Factory? Session Factory is an interface and extends referenceable, serializable, and which is available in org.hibernate package. Creates sessions. Usually, an application has a single session factory and it is long-lived multi-threaded object, so can say it's a thread safe. Usually, one session factory should be created for one database, so if have multiple databases then multiple session factories required. Session factories are immutable. The behavior of a session factory is controlled by properties supplied at configuration time. These properties are defined on environment. Here is the syntax. What is session? A session is used to get a physical connection with the database. The session object is lightweight and designed to be instantiated each time an interaction is needed with the database. Persistent objects are saved and retrieved to a session object. The session is not thread safe. Sessions are opened by a session factory and then are closed when all work is complete. A session obtains a database connection lazily, that is only when required, to avoid creating too many sessions. Here is the syntax. What is data source? Spring obtains a connection to the database through a data source. A data source is part of the JDBC specification and is a generalized connection factory. It allows a container or a framework to hide connection pooling and transaction management issues from the application code. Here is the syntax. Let's implement. Before starting anything, let's run and see whatever we added till now it's working fine or not. Server started. Let's open in browser. See, it's working fine. Now let's start Hibernate integration. Starts from pom.xml. Let's remove unit dependency because we are not adding any test cases. Let's add Hibernate related dependency. Let's search for Hibernate 4.3.0. Copy this and paste it in POM. Let's add MySQL-related dependency. Copy this and paste it in POM. Now let's add property file, which will keep adding database-related properties to make it simple. File name db.properties. Now I'm adding DB connection-related properties. Now let's create an XML file for Hibernate configuration, so file name must be hibernate.cfg.xml. Now let's search for this Hibernate configuration DTD file. Here it is. Let's copy these doc types. Now we can add Hibernate configuration whatever we are going to add, that is standard code. That's it for this file. Let's create bean property placeholders so we can read db.properties file. Now let's create Hibernate-related beans and Spring.xml file. Before that we need Commons DBCP-related dependency, means Commons Database Connection Pooling. From Apache documentation you can read about it. Let's copy this dependency in POM XML file. Now let's create database connection-related beans. Let's add a Spring ORM-related dependency to integrate Hibernate. Copy this and paste it in POM. create a package which will contain all model. As you can see, one being for the data source, and one for session factory and one for the transaction. We are using transaction, so need to add the transaction related namespace. See, everything is simple, only you need to follow proper step. Let's create a simple model class called employee, which will contain some simple fields. Need to add JPA related annotations. Let's run and see it's working or not. This error is coming because my SQL version is not compatible. Let's run again. See, server started. Let's review whatever we added. Let's check table is created or not. Not yet, so let's create DB and restart the server again. See table created. In this video, we will do some simple CRUD operations. Starts with simple login functionality. Before starting anything, let's run and see it's working fine or not. Server started. Whatever we added till now, it's working fine. Let's change all the label as per the model. Just to make it simple, change all the employee reference to the user. And restart the server, so like employee user table created in the database. Drop the employee table, add some dummy data in user table. Let's add some required changes in controller label, so based on user form add changes in login page like form tag lib of Spring. Now let's add some simple changes, so whenever the user clicks on login button it should validate username and password with database values. Before adding any database-related logic, first see user ID and password is printing or not. Let's restart the server. Now let's enter database username and password. Click on the login button. See user ID and password is printing in log. Now let's add required logic so it will authenticate the user from the database. Need to extend Hibernate now support class. Now let's add required logic, so in that logic initialize session factory and get the current session. Now we are ready to perform the database-related operation. See, it looks very simple. Instead of void, let's return a user object. Add basic checks and controller label, so if the wrong credential, then it should not go anywhere. Stay on the login page. That's it. Let's restart the server and see it is working fine or not. Server started. Let's check login is happening or not. Oops, giving 500. Let's see what is the reason. It's giving Hibernate exception, no session found for current thread. It is coming because we forget to add transactional annotation. Let's add that annotation. Let's restart the server. Server started. Let's check again. Oops, again 500, but now the exception is different. It's telling class case exception. Let's fix this. Forget to add the unique result. Let's restart the server. Server started. Let's check again. See, it's working fine. See, query also generated because we made it show SQL true. Let's enter the wrong credential. Now it's giving 500 error. It's coming because when you are entering the wrong credential, then not able to redirect. Let's add the redirect. Let's restart the server. Server started. Let's check again with the wrong credential. See, it is redirecting properly. Let's review whatever we added. this video, we will implement CRUD operations. Before starting anything, let's run and see what we added till now, it's working fine or not. Server started. See, it's working fine. Let's add some links so when you click on those it will perform some kind of CRUD operations. Now let's add Java code to perform these actions. Let's first implement fetching list from DB functionality. If you watched previous videos, then this time no need to explain each and everything. Let's run and see user list is coming or not. Server started. See the list is coming means in Cron retrieve is done. Now let's add changes for add new user. Add along with add link for edit and delete. Now let's add Java code to perform these actions. Let's add functionality. Before adding further changes, just check once everything is fine or not. Let's restart the server. Server started. See, everything is okay. Now let's add Java code to perform save actions. Save changes are done. Let's restart the server. Service started. See, save is working fine means in CRUD create is done. Let's add edit functionality. Let's add edit functionality. Let's restart the server. Service started. See, edit is working fine means in CRUD update is done. Let's add delete functionality. Let's restart the server. Service started. See, delete is working fine means in CRUD delete is done. Let's review whatever we added. In this video, we will see how to use p namespace, and this video is more like cleanup activity. Watch till the end, you will come to know what is p namespace. Spring's p namespace is an alternative to using the property tag. Using p namespace, we can perform dependency injection by directly using the attribute of being tag instead of using the property. P namespace is more compact than property tag. Using p namespace reduces the amount of XML required in Spring configuration. The size of Spring configuration using p namespace is typically less than 1 with using property tag. Here is the syntax. Let's implement. Before starting anything, let's run and see what we added till now, it's working fine or not. Server started. See, it's working fine. Let's first remove up stuff from Spring Servlet and keep it in a separate file. So to make it simple, file name should be Spring app. To make it simple, let's remove the versions from all the namespaces. Now need to import newly created file in Spring Servlet. Before add changes, all the places, let's make sure that everything is working fine or not. Let's restart the server. Server started. See, log is coming from aspect, means it's working fine. Let's get rid of Hibernate CFG file. There is a property called Hibernate properties in local session factory being class, so with the help of this property we can ignore CFG file. Now there is no need of CFG file, so let's delete this file. After remove Hibernate CFG, let's check it is working fine or not. Server started. See, it's working fine. Let's add p namespace so can replace property tagged with that. So after replace code become very less. Let's check everything is working fine or not. Service started. It's working fine. Let's change project presentation. Let's remove session factory init part also. Let's check once again it's working or not. Let's restart the server. Server started. See, it's working fine. Let's review whatever we added. In this video, we will see about EntityManager, what is EntityManager and Hibernate. Hibernate EntityManager implements the programming interfaces and lifecycle rules as defined by the JPA 2.0 specification. Together with Hibernate annotations, this wrapper implements a complete and standalone JPA persistence solution on top of the mature Hibernate core. The Entity Manager API is used to access a database in a particular unit of work. This interface is similar to the session in Hibernate. It is used to create and remove persistent entity instances, to find entities by their primary key identity, and to query over all entities. Here is the dependency. What is Entity Manager Factory? An Entity Manager Factory provides Entity Manager instances. All instances are configured to connect to the same database, to use the same default settings as defined by the particular implementation, etc. Interface used to interact with the Entity Manager Factory for the persistence unit. When the application has finished using the Entity Manager Factory, and/or at application shutdown, the application should close the Entity Manager Factory. You can prepare several Entity Manager Factories to access several data stores. This interface is similar to the Session Factory in native Hibernate. What is Local Container Entity Manager Factory Bean? Factory Bean that creates a JPA Entity Manager Factory according to JPA's standard container bootstrap contract. This is the most powerful way to set up a shared JPA Entity Manager Factory in a Spring application context. The Entity Manager Factory can then be passed to JPA-based DAOs via dependency injection. Note that switching to a JNDI lookup or to a local Entity Manager Factory Bean definition is just a matter of configuration. What is persistence context? The scope of this context can either be the transaction, or an extended unit of work. Entities are managed by javx.persistence.EntityManager instance using persistence context. Each Entity Manager instance is associated with the persistence context. Within the persistence context, the entity instances and their lifecycle are managed. Persistence context defines a scope under which particular entity instances are created, persisted, and removed. A persistence context is like a cache which contains a set of persistent entities, so once the transaction is finished, all persistent objects are detached from the Entity Manager's persistence context and are no longer managed. What is Hibernate JPA Vendor Adapter? JPA Vendor Adapter implementation for Hibernate Entity Manager. It's kind of one property of Entity Manager and contains some configuration like generate DDL, show SQL, format SQL, etc. Here is the way to create a bean. What is JPA Transaction Manager? This Transaction Manager is appropriate for applications that use a single JPA Entity Manager Factory for transactional data access. JPA, usually JPA Transaction Manager, is necessary for accessing multiple transactional resources within the same transaction. This Transaction Manager also supports direct data source access within a transaction. Here is the way to create a bean. Let's implement. Before starting anything, let's run and see everything is working fine or not. Server started successfully. Means everything is working fine. Let's search for the Hibernate Entity Manager dependency. We prefer the same version which we used last time, 4.3.0. Let's copy this and paste it in POM file. Now we'll replace Hibernate core with Hibernate Entity Manager dependency. Let's replace property placeholder bean with context property placeholder. Let's replace Session Factory with EntityManager Factory. And replace Hibernate Local Session Factory Bean with JPA Local Container EntityManager Factory Bean. Now instead of Hibernate properties, we will use JPA vendor adapter, and inside that, we will create a bean for Hibernate JPA vendor adapter. Now need to replace Hibernate Transaction Manager with JPA Transaction Manager and replace Session Factory property with EntityManager Factory. Let's add changes in the repository class. Replace all Session Factory code with the EntityManager. See how easily we replaced all Session Factory related code EntityManager Factory. Let's restart the server. Oops, exception. Let's check. Let's restart again. Server started, it's working. In case of edit, it's giving exception. Let's check. It's happening because we simply use persist. Now let's add some simple condition. So if new record then persist, otherwise merge. Let's restart again. Service started. See, it's working. Oops, now delete is not working. Let's restart again. Service started. See, now everything is working fine. Let's review whatever we added. In this video, we will see about Spring Data JPA. What is Spring Data JPA? Too much boilerplate code has to be written to execute simple queries as well as perform pagination and auditing. It aims to significantly improve the implementation of data access layers by reducing the effort to the amount that's actually needed. As a developer, you write your repository interfaces, including custom Finder methods, and Spring will provide the implementation automatically. We can remove some boilerplate code by creating an abstract-based repository class that provides CRUD operations for our entities. This means that we can create concrete repositories by extending that base repository class. It has a lot of customization points, including items like query auto-generation by convention, query hints, and auditing features. Sophisticated support to build repositories based on Spring and JPA. Support for queried style predicates and thus type-safe JPA queries. Transparent auditing of the domain class. Pagination support, dynamic query execution, ability to integrate custom data access code. Validation of query annotated queries at a bootstrap time. Support for XML-based entity mapping. Java config-based repository configuration by introducing enabled pair repositories. Advantages: don't need to write persisting, updating, deleting or searching logic. Reduce a lot of basic DB code. No need to create implementation classes to perform basic CRUD operations. Just extends repository class and it takes the domain class to manage as well as the type of domain class as type arguments and interface. The interface acts as a marker interface to capture the type of work and to help you to discover interfaces that extend this one. Types of repositories: repository, CRUD repository, paging, and sorting repository, JPA repository. Let's implement. Before starting anything, let's run and see everything is working fine or not. Server started. See, everything is working fine. Let's first add required Spring Data JPA Maven dependency. Let's copy this and paste it in POM XML file. Need to add the namespace in the XML file, so let's search for the namespace. Open Spring documentation, copy this line and use in Spring.xml. Need to change base package instead of component scan, should use JPA repositories. Now no need of DAO implementation class because we will extend JPA repository interface. Now need to change calling method name in the service class. See how simply we are modifying all the things. You can see we removed a lot of code because of Spring Data JPA. You can use custom query also using query annotation. Let's restart the server and see it's working fine or not. Oops, exception is coming. Let's check. Naming policy is coming because of Spring App dependency is missing. Let's search for Spring App. Let's copy this and paste it in POM XML file. Let's run again and see it's working or not. Server started successfully. Login is happening properly. List is coming. Add is working. Delete is working. Edit is working. So basically everything is working fine. Let's review whatever changes we added. Let's do some POM XML code modification, make it separate dependency version. It makes easy to modify. In this video, we will see how to execute cron job, Spring task. Spring Framework has built-in support for scheduled tasks, so can schedule tasks using XML as well as annotation also. Here is the syntax for XML. Annotation, an annotation that marks a method to be scheduled. Exactly one of the cron, fixed delay, or fixed rate attributes must be specified. Processing of scheduled annotations is performed by registering a scheduled annotation being post-processor. This can be done manually or, more conveniently, through the task annotation-driven element or enable scheduling annotation. Let's implement. Before starting anything, let's run and see it's working fine or not. Service started. See it's working fine. Create a new XML file. To make it simple, file name should be Spring Cron. Import this file into Spring context. Copy basic file content from Spring app. Replace up with the task. Let's create a separate package for cron-related class. Create a class. Class name should be execute using bean. Before going further, let's check the task namespace is correct or not. Yes, correct one. Create a bean for newly created class. Task schedule task. Inside that task schedule, two attributes reference should be bean and method, which we are going to create and execute using bean. Method name we are using run, so it will search run method and execute using bean class and execute according to cron expression. Let's search about cron expression for every 5 seconds. To learn about cron expression, you can refer this website. Let's search for generate cron expression. You can generate cron expression also from Cron Maker website. Convert this expression to execute every 5 seconds. Now let's add run method and execute using bean class. Put some print message so come to know it's executing. That's it. Let's see after running cron job is executing or not in every 5 seconds. Service started, see it's executing. Let's implement using annotation. Create a class. Class name should be execute using annotation. Follow the same steps as we followed for bean. That's it. Create a run method like we did for execute using bean class. Instead of 5, this time we will execute this in every 10 seconds. Need to annotate this method as scheduled and set value for cron. Let's run and see it's working fine or not. Service started, see it's executing. Let's review whatever we did. In this video, we will see how to integrate Quartz Scheduler. What is Quartz framework? It is an open-source job scheduling framework that lets you schedule a task to run on a predefined date and time and can be integrated within virtually any Java application, from the smallest standalone application to the largest e-commerce system. It can be used to create simple or complex schedules for executing tens, hundreds, or even tens of thousands of jobs whose tasks are defined as standard Java components that may execute virtually anything you may program them to do. The Quartz scheduler includes many enterprise-class features, such as support for JPA transactions and clustering. It is an open-source product from the Ehcache company. Quartz dependency. When integrating with Spring, need to add Spring context support dependency also. It's a kind of mediator and provides some classes which help to integrate with Quartz. Spring context support dependency. Let's implement. Before starting anything, let's run and see everything is working fine or not. Server started. See, whatever we added till last video, it's working fine. The job is executing automatically in every 5 and 10 seconds. Let's implement using third-party Quartz scheduler. Let's search for Quartz scheduler Maven dependency. Let's copy this and paste it in POM XML file. To integrate Quartz, we need Spring context support dependency also. Let's search for this. Let's copy this and paste it in POM XML file. To learn about Quartz scheduler, you can refer this website. Let's create separated XML file for Quartz configuration. To make it simple, file name should be Spring Quartz XML. Modify this file accordingly. Let's create separate package for Quartz. The class name should be execute using Quartz. Copy run method from execute using bean class. Modify the print message. We'll execute this in every 15 seconds. Let's create a bean for execute using Quartz class. Let's create a bean for method invoking job detail factory bean. And inside that, add target object reference and target method. Let's create a bean for Cron trigger factory bean. And inside that, add job details reference and cron expression. Need to create one more bean for scheduler factory bean. And inside that, add triggers reference. Let's run and see it's working or not. Server started. Oops, not working. We forgot to import Quartz XML file. Let's import newly created file. Let's run again and see it's working or not. Server started. See, it's working fine. Let's review whatever changes we added. Scheduler Factory Bean. Factory Bean that creates and configures a Quartz scheduler, manages its lifecycle as part of the Spring application context and exposes the scheduler as being referenced for dependency injection, allows registration of job details, calendars, and triggers, automatically starting the scheduler on initialization and shutting it down on destruction. In scenarios that just require static registration of jobs at startup, there is no need to access the scheduler instance itself in application code. For a dynamic registration of jobs at runtime, use the bean reference to the scheduler factory bean to get direct access to the Quartz scheduler, org.quartz.scheduler. This allows you to create new jobs and triggers, and also to control and monitor the entire scheduler. Note that Quartz instantiates a new job for each execution, in contrast to Timer, which uses a timer task instance that is shared between repeated executions. Just job detail descriptors are shared. When using persistent jobs, it is strongly recommended to perform all operations on the scheduler within Spring Managed or plain JPA transactions, else database locking will not properly work and might even break. See set data source Javatic for details. The preferred way to achieve transactional execution is to demarcate declarative transactions at the business facade level, which will automatically apply to scheduler operations performed within those scopes. Alternatively, you may add transactional advice for the scheduler itself, compatible with Quartz 1.8 as well as Quartz 2.0.2.2. As of Spring 4.0, note Quartz 1.x support is deprecated. Please upgrade to Quartz 2.0. Cron Trigger Factory Bean. A Spring Factory Bean for creating a Quartz Cron trigger instance supporting bean-style usage for trigger configuration. Cron trigger itself is already a Java bean but lacks sensible default. This class uses the Spring Bean name as job name, the Quartz default group, default, as job group, the current time as start time, and indefinite repetition, if not specified. This class will also register the trigger with the job name and group of a given job detail. This allows Scheduler Factory Bean to automatically register a trigger for the corresponding job detail, instead of registering the job detail separately. Note this Factory Bean works against both Quartz 1.x and Quartz 2.x, in contrast to the older Cron Trigger Bean class. Method invoking job detail Factory Bean. Factory Bean that exposes a job detail object which delegates job execution to a specified, static or non-static, method. avoids the need for implementing a one-line Quartz job that just invokes an existing service method on a Spring-managed target bean, inherits common configuration properties from the method invoker base class, such as target object and target method, adding support for lookup of the target bean by name through the target bean name property, an alternative to specifying a target object directly, allowing for non-singleton target objects, supports both concurrently running jobs and non-currently running jobs through the concurrent property. Jobs created by this method invoking job detail factory bean are by default volatile and durable, according to Quartz terminology. Note: job details created via this factory bean are not serializable and thus not suitable for persistent job stores. You need to implement your own Quartz job as a thin wrapper for each case where you want a persistent job to delegate to a specific service method. In this video, we will learn about Spring Batch. What is Spring Batch? A lightweight, comprehensive batch framework designed to enable the development of robust batch applications vital for the daily operations of enterprise systems. Spring Batch provides reusable functions that are essential in processing large volumes of records, including logging, tracing, transaction management, job processing statistics, job restart, skip, and resource management. It also provides more advanced technical services and features that will enable extremely high volume and high performance batch jobs through optimization and partitioning techniques. Simple as well as complex, high-volume batch jobs can leverage the framework in a highly scalable manner to process significant volumes of information. Features: transaction management, chunk-based processing, declarative I/O, start/stop/restart, retry, skip, web-based administration interface, Spring Batch admin. How to execute Spring Batch manually. The job tier is responsible for the overall execution of a batch job. It sequentially executes batch steps, ensuring that all steps are in the correct state and all appropriate policies are enforced. The job tier is entirely concerned with maintaining the three job stereotypes: job, job instance, and job execution. The job launcher interacts with the job repository in order to create a job execution, and the job stores the job execution using the repository. Let's implement. Before starting anything, let's run and see whatever we added till now it's working fine or not. Service started. See, it's working fine. Let's add Spring Batch core dependency. Let's copy and paste it in POM XML file. Let's create a separate XML file for batch configuration. To make it simple, XML file name must be Spring Batch XML. Import this newly created file in Spring Context XML. Let's search for Spring Batch namespace. To learn about Spring Batch, so read about for Spring document. Let's copy Spring Cron content and paste it in Spring Batch. Let's modify this file. Let's add Spring Batch namespace, so copy from Spring document. Let's create a bean for the resource list transaction manager. Now let's create a bean from map job repository factory bean. Add transaction manager as a reference for this bean. What is the job repository? Job repository is responsible for the persistence of batch metadata entities. Simple job repository is the implementation of job repository that stores job instances, job executions, and step executions using the injected DAOs. A factory bean, map job repository factory bean, that automates the creation of a simple job repository using non-persistent in-memory DAO implementations. This repository is only really intended for use in testing and rapid prototyping. In such settings, you might find that resourceless transaction manager is useful, as long as your business logic does not use a relational database. Not suited for use in multi-threaded jobs with splits, although it should be safe to use in a multi-threaded step. Now let's create a bean for simple job launcher. What is job launcher? Simple interface for controlling jobs, including possible ad hoc executions, based on different runtime identifiers. It is extremely important to note that this interface makes absolutely no guarantees about whether or not calls to it are executed synchronously or asynchronously. A simple implementation of the job launcher interface. The Spring Core Task Executor interface is used to launch a job. This means that the type of executor set is very important. If a sync task executor is used, then the job will be processed within the same thread that called the launcher. Care should be taken to ensure any users of this class understand fully whether or not the implementation of task executor used will start tasks synchronously or asynchronously. The default setting uses the asynchronous task executor. There is only one required dependency of this launcher, a job repository. The job repository is used to obtain a valid job execution. The repository must be used because the provided job could be a restart of an existing job instance, and only the repository can reliably recreate it. Add job repository as a reference for this bean. Now let's create a bean from map job registry. Now let's create a bean for job registry bean post processor. What is job registry and registry bean post processor? A runtime service registry interfaces for registering job configurations by name. Map job registry is a simple, thread-safe, map-based implementation of job registry. A bean post processor that registers job beans with a job registry. Include a bean of this type along with your job configuration, and use the same job registry as a job locator when you need to locate a job to launch. Add job registry as a reference for this bean. Now let's create a bean for map. Add code for batch job tag. Create a separate package for Spring Batch. Create a class called ExecuteTasklet. Create a bean for ExecuteTasklet. Add params in ExecuteTasklet. Implements interface tasklet. What is tasklet in Spring? It is a strategy for processing in a step. Declares the implementation of the tasklet strategy indirectly by configuring a chunk or directly by configuring a reference to the tasklet interface. Given the current context in the form of a step contribution, do whatever is necessary to process this unit inside the transaction. Implementations return repeat status.finished if finished. If not, they return repeat status.continuable, on failure throws an exception. Add a reference for params. Add some logic in ExecuteTasklet. Let's create the controller which will take care of the request sent from the front end. To make it simple, controller name Job Launcher Controller. Add basic code in Job Launcher Controller. That's it. Add one link to execute this batch job through Job Launcher controller. Task name should be matched with job ID. Let's run and see it's working fine or not. Service started. Let's check from the browser. Let's change the Cron expression for bean, annotation and Quartz so can see only manually job detail. The request is coming tell controller but not execute tasklet. Before fix issue, let's change Cron expression for others. Let's run again and see it's working fine or not. Service started. Not execute tasklet, that is only responsible for batch job. Tasklet not executing because running job message is not printing. It's not executing because get value casting is not proper. Let's run again. Service started. See, now it's working. Let's expose the user service from tasklet. Let's run again and check result is coming or not coming from service. See it's coming so same way can expose any service which contains a lot of calculation. Let's review whatever we added to execute batch job manually. Map job repository factory bean, a factory bean that automates the creation of a simple job repository using non-persistent and memory DAO implementations. This repository is only really intended for use in testing and rapid prototyping. In such settings, you might find that resourceless transaction manager is useful as long as your business logic does not use a relational database. Not suited for use in multi-threaded jobs with split, although it should be safe to use a multi-threaded step. Simple job controller. a simple implementation of Job Launcher interface. The Spring Core Task Executor interface is used to launch a job. This means that the type of executor set is very important. If a sync task executor is used, then the job will be processed within the same thread that called the launcher. Care should be taken to ensure any users of this class understand fully whether or not the implementation of task executor used will start tasks synchronously as asynchronously. The default setting uses the asynchronous task executor. There is only one required dependency of this launcher: a job repository. The job repository is used to obtain a valid job execution. The repository must be used because the provided job could be a restart of an existing job instance, and only the repository can reliably recreate it. Job Registry Bean Post Processor. A bean post processor that registers job bean with a job registry. Include a bean of this type along with your job configuration, and use the same job registry as a job locator when you need to locate a job to launch. Defines a job composed of a set of steps and transitions between steps. The job will be exposed in the enclosing bean factory as a component of type job that can be launched using a job launcher. Defines a stage in job processing backed by a step. The ID attribute must be specified. The step requires either a chunk definition, a tasklet reference, or a reference to a possibly abstract parent step. Declares the implementation of the tasklet strategy indirectly by configuring a chunk or directly by configuring the reference to a tasklet interface. We will learn about Ehcache. What is Ehcache or second-level cache? Ehcache is an open standards-based cache for boosting performance, offloading your days, and simplifying scalability. As a robust, proven, and full-featured solution, it is today's most widely used Java-based cache. You can use Ehcache as a general-purpose cache or a second-level cache for high. Caching is facility provided by ORM frameworks which help users to get fast-running web application, while help framework itself to reduce the number of queries made to the database in a single transaction. In Hibernate by default enabled first-level cache, so need to add some configuration to enable Ehcache or second-level cache. How does cache work internally? Cache. A cache means a store of things that will be required in future, and can be retrieved rapidly. Or a cache is a collection of temporary data which either duplicate data located elsewhere or is the result of a computation. Once in the cache, the data can be repeatedly accessed inexpensively. Cache hit. When a data element is requested of the cache and the element exists for the given key, it is referred to as a cache hit, or simply hit. Cache miss. When a data element is requested of the cache and the element does not exist for the given key, it is referred to as a cache miss, or simply miss. System of record. The core premise of caching assumes that there is a source of truth for the data. This is often referred to as the system of record, SOR. The cache acts as a local copy of data retrieved from or stored to the system of record. This is often a traditional database, although it may be a specialized file system or some other reliable long-term storage. For the purposes of using Ehcache, the source is assumed to be a database. Let's implement before starting anything. Let's run and see everything is working fine or not. Service started. See, everything is working fine. Every time refresh the user list page, it hits the database. Let's integrate second-level cache or Ehcache. Search for Ehcache Maven core dependency. Copy this and paste it in POM XML file. Let's create a separate XML file for cache. To make it simple, file name should be Spring Cache. Import this file into Spring context. Now let's modify accordingly. Search for Ehcache Spring namespace. Let's copy this and paste it in Spring Cache XML file. Need to enable cache annotation. Create a bean for Ehcache Cache Manager. Create a bean for Ehcache Manager factory bean. Need to create one more file for Ehcache. To make it, simply create a separate folder called cache. Create a new file called Ehcache XML. Search for default format of Ehcache XML. Copy this and paste it. And copy this default cache code. Let's give name users. Now let's see how to use this user's cache in the service class. But before that, add this file location in config location. We want this cache for the user list, so add annotation called cacheable and pass the value as users. That's it. Let's run and see it's working fine or not. Service started. Oops, giving exception. Let's fix it. Giving cache exception, like when configured copy on read or copy on write to store, will only accept serializable values. Let's implement serializable interface for user class. I hope you got the point. If yes, then add in a comment. Let's run again. Service started. See, it's working now. Let's refresh multiple times and see it's hitting database every time or coming from cache. See, it's not hitting, the result is coming from cache. Let's add some more properties in Ehcache XML file. Search for Ehcache persistence strategy example. Like local temp swap, enables temporary local disk space. This option provides an extra tier for storage during cache operation, but this disk storage is not persisted. After a restart, the disk tier is cleared of any cache data. Let's run again and see if there's any difference. You won't feel any difference, but like that, there are many properties so you can use as per your requirement. Service started. See, the list is refreshing multiple times but not always hitting the database. Let's add some more properties in Ehcache XML. Like memory store eviction policy. LRU, least recently used. LFU, least frequently used. FIFO, first in first out. So like that, let's modify some more. Let's run again. Service started. See, it's working, but now it works but not as expected. It's happening because of copy on read and copy on write true. So let's remove both the property and add a new property like disk spool buffer size MB. Let's run again. Service started. See, now it's working as expected. Let's review whatever we added. In this video, we will learn about message source. What is resource bundle message source? Message source implementation that accesses resource bundles using specified base names. This class relies on the underlying JDK's resource bundle implementation, in combination with the JDK's standard message parsing provided by message format. This message source caches both the accessed resource bundle instances and the generated message formats for each message. It also implements rendering of no-arg messages without message format, as supported by the abstract message source base class. The caching provided by this message source is significantly faster than the built-in caching of the resource bundle class. Unfortunately, resource bundle caches loaded bundles. Forever reloading a bundle during VM execution is not possible. As this message source relies on resource bundle, it faces the same limitation. Consider reloadable resource bundle message source for an alternative that is capable of refreshing the underlying bundle files. Let's implement. Before starting anything, let's run and see everything is working fine or not. Service started. See, it's working fine. Let's read all these labels from messages properties files. Let's create a file under the resources folder, and file name should be messages and properties. To increase the font directly, press Ctrl+, and to reduce Ctrl-. Let's create a bean for resource bundle message source. Add a base name property. Now add a label and a property file. To access those labels, need to add tag library of Spring. See, it's very simple. Let's run again and see labels are coming from a properties file or not. Service started. See, it's coming from message and properties file. Let's move all labels. Let's run again, see whatever changes we added just now it's coming or not. Let's replace other page labels. See all labels replaced. Let's run again, see it's working or not. Oops, 500 internal server error is coming, because we missed one label. Now just reload this page, see it's showing properly. Let's review whatever we added. In this video, we will learn about internationalization. What is internationalization and how to implement? Internationalization, it's nothing but the count between I to N, so in short, internationalization. Follow below steps to implement. Locale change interceptor that allows for changing the current locale on every request, via a configurable request parameter, default parameter name, locale. Session locale resolver implementation that uses a local attribute in the user's session in case of a custom setting, with the fallback to the specified default locale or the request's accept header locale. This is most appropriate if the application needs user sessions anyway, that is when the HTTP session does not have to be created for the locale. The session may optionally contain an associated time zone attribute as well. Alternatively, you may specify a default time zone. Custom controllers can override the user's locale and time zone by calling set locale context on the resolver. Example, responding to a locale change request as a more convenient alternative. Consider using request context change locale. Let's implement. Before starting anything, let's run and see everything is working fine or not. Service started. It's working fine. Let's first enable MVC interceptors. Now create a bean for locale change interceptor. Let's create a bean for session locale resolver. Let's create a new file for the Spanish language. File name must be messages_s.properties. Now let's convert all labels from English to Spanish. Let's run and see it's working fine or not. Service started. Working fine for English. Now add locale as a query parameter. Same way, change it to S. See, it's working fine. Let's review whatever we added. Thanks for watching. If you liked this video, then please click the like button. We will come back shortly with new video. Till the time, happy learning.